we are taking our last chunk of learning for this particular unit and using it to look at square root graphs. So we could look at cube roots, we could keep going all higher and higher, but we're just going to focus on square roots. And specifically, we're going to talk about transformations. In other words, moving it left or right and up or down, talking about how that impacts the domain and the range. So two kind of key vocab words. Domain, of course, tied to the x values, range tied to the y. I promise I will go back and talk about that again. But let's take a second and talk about what a square root graph looks like and where it comes from and kind of how it all fits together. So for our work, we are going to, let's just start with a table. So most of the time, you guys know if I'm doing a table, I go -2 to +2. Well, I'm going to change my x's up a little bit here. And the reason I'm changing them is because I want very specific points. And then on the y side, I'm just going to use the square root of x to get my ordered pair. So for example, square root of -1 is I. We're just going to say not graphable. We're not doing anything with imaginary numbers. We're just going to leave it. Okay, so we're not going to graph it at all. Square root of 0 is 0, which means I have an ordered pair at 0, 0. Square root of 1 is 1, an ordered pair at 1, 1. Square root of 4 is 2, so I have an ordered pair at 4, 2. And then the square root of 9 is 3, and so I am going to do my best to make it work to get an ordered pair at 9, 3. And I end up with sort of this I'm a little teapot looking arm thing going off in the distance like so. It actually looks like half of a parabola, right? If we kind of turn the parabola onto its side. And as we're looking at this, notice the graph starts at x0 and it starts at y0 and goes up from there. So we're starting at 0, 0, and that's how our graph lives. If we wanted to break this down, we would say some things about the domain, which means what are the x values of this graph? And in this graph, x is always bigger than 0. So in other words, here's where x is 0, and we're going to get all the points going that way. Everything bigger than 0 is accounted for. As far as the range, that represents all the y values. And in this problem, the y values are all greater than 0. So we start at that axis and we move from there. Now, these domain and this range are related to some information that we can see in the equation. So, okay, well, when I look at that information, here's what I've got. If I've got this, I've got the square root part, and under that square root, I can either add or subtract h. If I add h, that means my graph's going to move to the left because x lies. If I subtract h, I'm going to move to the right because x lies. I also can do something outside of the square root using the letter k. If I add k, I go up. If I subtract k, I go down. And it's up to us to recognize when am I in the square root and when am I out of the square root. And what does that mean for things? So let's go through 4 examples real quick. I think that might be a good place for us to start. If I can get my x's and y's to line up fairly nicely, we'll go with it like that. Here's what we're doing. I'm going to start with just some moving left and to the right. So here's my first 2 examples. Y equals the square root of, not just x plus 2. And y equals the square root of x minus 2. And so as I look at this, that x plus 2, this plus 2, first of all, it's under the square root, so we know it's changing the x, but x lies, and so this is moving our graph left 2 places. And so we're going to move left 1, left 2, and our graph is going to start here, and then it's going to do its thing. Okay? That means our domain has changed. It is now x is greater than or equal to negative 2 because that's where I put the new graph. In this next one, x minus 2, the minus 2, x of course lying liar, it's going to move it to the right. So my whole graph is going to pick up and move right 2 places. And as I look at that, I put my point now at this new starting spot, and my graph launches from there. Because it moved in the x's, the domain changed. The domain is now x is greater than or equal to positive 2. Okay. Something to notice, the range did not change because we didn't move it up or down. If we would have moved it up or down, like we're about to, then we would obviously account for that by moving the range the same amount. So, moving it left or right impacts the domain, and we can kind of see how it does that. Let's look at moving it up or down. You'll notice, hopefully, that when we move it up or down, we have now stepped outside of the square root and are now doing all of our changes on the outside. And the whole point of doing changes on the outside is that we're moving now the entire graph either up or down. The outside does not lie. So when it says plus 2 like that, that means our whole graph is moving up 1, up 2. If it says minus 2 like in this one, that means our entire graph is moving down 2. Down 1, down 2. We're just picking it up and redrawing it down below. So this particular graph moving up 2, we get something like this. Moving down 2, we get the same graph, just further down like so. Now, because we moved the graph, we impact the domain and the range. So the range here is y is greater than or equal to 2 because now it's moved up. And the next one, negative 2. And just so you're aware, in both of these problems, the domain did not change because we didn't move it left or right. So if we would have moved it, what is that? If we would have moved it left or right, then we would have had to account for what did moving it left or right do to the domain, what did moving it left or right do to the range. Sorry, what did moving it up or down do to the range. So if you make 2 moves, you're going to have 2 kind of key pieces to account for. So just be mindful of that. Otherwise, here's kind of square root graphs. One final little tidbit is as you are drawing them, please don't stress about how they look or how perfect they are. Just know that you're kind of launching from a certain spot and it's going to follow that similar shape, but please don't stress about how perfect it is because we're not too worried about how good our graph looks, more just about where it lives. So you got this. Be in touch if there's anything you need.